3, lesson 19. This opens up in your book on page 138. It's going to cover a couple things: nonlinear systems, factoring exponentials, sum and difference of two cubes. So there's a lot being involved here. Your first 4 questions up here are nonlinear systems. Okay, so when we're talking about nonlinear systems, we're talking about things like ellipses, hyperboles, circles, those types of things. Okay, things that we could graph on a coordinate plane but are not lines. Okay, something that has a curve to it. All right, factoring exponentials is what we see in questions 5, 6, and 7. And then on our last part here, which is sum and difference of two cubes, is questions 8, 9, just questions 8 and 9. Okay. All right. So when it comes to solving a system, right? Even whenever we were doing solving systems of linear equations, right? Solving 2 lines. Our solution was where those 2 lines crossed at, correct? Okay. It's not different here. Our solution for our systems are the locations or the coordinates where these systems cross at. What we have to figure out, though, is what kind of systems are being represented by our equations here. For instance, I know I've taught this. It may just be gone from you, right? But question number 1, this top equation here is the equation of a circle. Okay, I don't know if you remember this or not, but the equation of a circle is x minus h squared, I believe, plus y minus k squared equals r squared. But in the event that h and k represent the coordinates of the center of the circle. In the event that the coordinates of the center of the circle are 0, it reduces to x squared plus y squared equals r squared. Do we see that with this right here? The center of the circle, based upon that equation, is 0, 0, and it has a radius of 5. Do we understand why it has a radius of 5? Okay, and not 25. Okay? All right, so everybody's on board with that. Great. All right, so what I want you to understand is that on a coordinate, that's that equation there. Now we have to determine what the second equation is. Well, the second equation is the equation of a line. It's just not in slope-intercept form, right? It's x plus y equals 5. We could easily rewrite that as y equals negative x plus 5, correct? Okay, so if my line is passing through my circle, okay, and I could draw any line, but if it crosses through the circle, unless it's a tangent line, or it doesn't intersect the circle at all, right? How many times is a line going to intersect a circle? At most, how many times? All right, so I should be looking for at most 2 solutions. And in all of these equations that I've looked at, and over the years of going through this, every time I find there's 2 answers, okay? Or 2 sets of coordinates, okay? So you should wind up with 2 x values and 2 y values. So this is the process that we take for solving when we have a circle and a line. Okay, we've got x squared plus y squared equals 25. And what I would do is take this equation, this line equation, and solve for one of the variables. For instance, let's go ahead and make it a line where we have y equals negative x plus 5, right? What that allows me to do is now I can, because this is y equals, I can substitute that into the circle equation. Okay, does that make sense? All right. So what I would end up doing is rewriting this so that I get x squared plus parentheses negative x plus 5 squared equals 25. All right, so I'm going to go ahead and erase my equation of a line. All right, just so I can ask this question. Negative x plus 5 squared, what am I doing with that? Foiling. Okay, good. So we see that. X squared, and I'm getting negative x times negative x. What is that? Positive x squared. All right, I'm getting negative x times 5. That's going to be negative 5x, right? I'm getting 5 times negative x. That's going to give me negative 5x. I'm getting 5 times 5, which is 25. Okay? You follow me through that? Okay? All right, let's go ahead and combine some like terms. What's x squared and x squared? Good, 2x squared. I got negative 10x plus 25 equals 25. Okay? Now, if I'm going to solve a quadratic equation, right, what am I going to have to do with the right-hand side of this equation? Yeah. Subtract 25, right? Subtract 25, subtract 25. I'm getting something like 2x squared minus 10x, what? Plus 0, right? Plus 0 equals 0. Okay? Does everybody understand how we got to 2x squared minus 10x plus 0? Okay, great. So I'm going to erase what's up here. Okay, keep in mind you do have the video, so you can pause, go back, rewind, do all that kind of cool stuff. All right, we're going to go ahead and plug this into the quadratic formula so that I'm getting 10 plus or minus negative 10 squared minus 4 times what? 2 times 0. Okay, that ought to make my life a little bit easier. And 2 times 2, right? So I've got 10 plus or minus over 4. All of that, the negative 4 times 2 times 0 cancels out, right? And I wind up with negative 10 squared, which is 100. So I got the square root of 100, but that square root reduces to 10, right? So we can rewrite that as 10 plus or minus 10 over 4. All right, now keep in mind, what are we solving for in all of this? You don't remember? Well, not x and y. Remember, I plugged in to this top equation here. But I substituted in, right, for y equals, so I should be solving this whole thing for x. Okay? So I'm getting two solutions here. What's 10 plus 10? 20. 20 divided by 4 is? So x equals 5. And x equals, well, what's 10 minus 10? 0. All right, so I get two x solutions. I get x equals 5 and x equals 0. Are we following me so far? Okay, so we know how to do that. Now all I have to do is solve for y. Okay, well, I can solve for y by coming back into my linear equation, because I just need to solve for y, right? And say, well, 5 plus y equals 5, and 5 plus 0 equals 5. Or I'm sorry, 0 plus y equals 5. Okay? Well, up here, right? What does y equal whenever x equals 5? 0. And what does y equal here whenever x equals 0? 5. So my two sets of coordinates are 5, okay, for my x and 0 for my y, and 0 for my x and 5 for my y. Those are my two coordinates, 0, 5 or 5, 0, or really more likely and. Does this make sense? So this is the basic process that you go through whenever you're dealing with a circle and a line. Okay? All right, do we have that? Good. Okay. All right, next up. Do we notice anything about number 2, what the top equation represents? A circle again. And you may be less familiar with the bottom one, but the bottom one is a hyperbole. Okay, so I'm getting something that could be, okay, that, and a hyperbole is going to be like that. Okay, so how many points do I cross at with a hyperbole in a circle? 4. Okay, so I need 4 solutions. That looks like a baseball. I'm just going to call it what it is. Okay, that's what it looks like. Okay. All right, so let's go about, this looks like it would be really hard to solve though, right? It looks like that, but this one's actually nicer than the last one. in terms of how long it actually takes to solve, because my terms are in x squared, y squared for each of them. Okay? In that, if I look at it like this, and I want to get it down to one variable, does anybody know what the easiest way to do that is? Could I use elimination here? Okay? What would I have to do to these two equations to eliminate? How about just subtract? What's x squared minus x squared? Okay, so it cancels out. Now I have to be careful here because I have 1y squared minus negative 4y squared. So plus, so I have 1 plus 4, so I get what? 5y squared. All right, now I have to remember 144 minus 64. 80. All right, so now I'm just solving for y. What do I do here? Divide by 5. Okay, so I have y squared equals what? What's 80 divided by 5? 16. One more step. I can't leave it as y squared. Square root. What does y equal? All right, and here's the thing that you got to remember, is that because we square rooted a square root over here, my answer is plus or minus 4. That'll be the part that's forgotten. Okay? So as I come over here, I get y equals 4. I get y equals negative 4. Okay? Now you're going to say, well, why don't we have 4 solutions, right? Why don't I have 4 y's? Because for my y equals 4, there's a positive and a negative x. Okay? For my y equals negative 4, there's a positive and negative x. Okay? So there's more than just one x for each of those y's. Okay? So we have this. I'm going to go ahead and erase here. Okay? So now I can substitute. Okay? We're going to start off. I'm going to use the equation of the circle because it's positive. So we've got x squared plus 4 squared, right? We'll use our positive equals 144. Okay, x squared plus 16 equals 144. Subtract 16 from 144, what do you get? 128. All right, and I'm going to square root my square. All right, so x equals positive or negative what? Doesn't come out all nice and neat though, does it? All right, so I'm going to come over here. 128 is 2 and 64. Of course, that's 8 and 8, right? Okay, so I get positive or negative 8 radical 2. So my 4 coordinates come out to, I get positive 8 radical 2 with 4. I get negative 8 radical 2 with 4. I get 8 radical 2 with negative 4. I get, let's see, and I get negative 8 radical 2 with negative 4. Those are my 4. Okay? Do we understand that? I've got 4 solutions there. So I get every combination of positive and negative with my x and my y. Okay, because of the squares. All right, I'm going to keep moving. All right, number 4 is just like number 1. Okay, do we see that? So do I need to solve out number 4 for you? I know, I'll go back to it. I just want you to be aware. Okay, so on number 4, your solution is 0, 3, 3, 0. So you get D as an answer. It's just something so you know, hey, if I go back and try this, you want to practice at it. That's what I'm going to get. Okay, you want number 3. Okay. Number 3 is a hyperbole and a line. Okay. And here I should just get 2 solutions. So imagine I have something like this, right? I'm going to get 2 solutions there. Okay. All right, so same basic concept on number 3 is that we can solve that for a variable, right? Take our linear equation, solve it for a variable. In this case, so on our 4 down here, or sorry, number 3, okay, I would add 3x to the other side, right? There's no y-intercept, so then I would divide by 2. So I'm going to get an equation where y equals, what, 3 halves? Y equals 3 halves. Make sure. 3 halves x. Okay? So now I can come back into this top equation. I can say 3 halves x squared minus x squared equals 5. Okay? Well, what's 3 halves squared as a fraction? Improper fraction. 3 halves squared. What's 3 squared? What's 2 squared? 9/4 x squared minus x squared equals 5. Okay, I think that you guys get this so far. What's 9/4 minus 1, or 9/4 minus 4/4 would be what, 5/4? Okay, 5/4. Okay, so 5/4 x squared equals 5. Okay, now I can't divide by 5/4, but I can multiply by 4/5. So what is 5 times 4? What's 20 divided by 5? 4. Okay, so I get x squared equals 4. Okay, so x is going to equal positive and negative what? 2. Okay, now that I know that, okay, we can come back into our equation of a line and plug in. So let's see, make sure I'm in the right spot here. So I got 2y minus 3 times 2 equals 0, right? And I have 2y minus 3 times negative 2 equals 0. Okay, we're going to solve for each of those y's. What's negative 3 times 2? Negative 6. So I have 2 minus 6 equals 0. Add 6 to the other side, right? So I have 2y equals 6. 6 divided by 2 is 3. So if I have positive 2, I have a positive 3, correct? All right. Negative 3 times 2 is positive 6. I would subtract 6 to the other side. Okay, 6 divided by 2, 3. Okay, or hold on, make sure. Negative 3, because it was a negative 6. All right, so if I have negative 2, I have negative 3 for a solution. All right, do we understand how to solve these? Okay, there's some very specific steps. Okay, let's keep on moving. Okay, that covers all of 1 through 4. Let's see, number 5. Okay. It says factor 6x to the, oh gosh, it's tough to see, 4n plus 2 plus 4x to the 6x minus 1 once that factored. Okay, so this is how we're going to do this, or how we're going to show it. We're going to break everything down into prime factorization. So 6 breaks down into 2 times 3. Okay? My x's here, I have 4 n's. So that's x to the n times x to the n times x to the n times x to the n, correct? Okay, that would give me 4 n's, right? Okay? And then times x, right, would give me the plus 2. Does that make sense? Okay? Plus 4, okay, that's 2 times 2 times, I think this is going to be n, x to the 6n, so x to the n, x to the n. 1, 2, 3, 4, 5, 6. And then x to the negative 1. Okay? I'm just showing it in expanded form so that you're going to be able to understand this, okay? So if we want to factor it, that means we're trying to find out what's common to both of them, okay? They both have a 2, right? Okay? They both have x to the 4n, right? This has 1, 2, 3, 4 n's. 1, 2, 3, 4 n's, right? Yes? Okay. Let's see. From here on, it gets maybe a touch more tricky because here, we know we're going to have a 3. It's that 3 there. And we actually could take these 2 and do plus 2 out here and go ahead and cover those so that we would get just 3 plus 2x to the 2n, but then we would do minus 3 because 2, positive 2 minus 3 is going to give me my negative 1. Does that make sense? The trickiest part there is dealing with that negative 1 versus the 2 over here. So if you have to just understand how adding exponents works, okay? So that's what we get when we factor it. I would say break it out into expanded form and then take the parts. Take the parts they have in common. Okay? Let's look at number 6. Again, it's hard to read. So we've got x to the 10b minus y to the 10b over x to the 5b plus y to the 5b. I'm going to give you guys a trick on this. Let's see if this works or not. I think this always works. It does always work. Your answer to these questions is always going to be the denominator with the opposite sign. Your answer is going to be x to the 5b minus y to the 5b. So if you look down here, your answer is x to the 6e plus y to the 6e. It's always the denominator with the opposite sign. Does that trick work for you? I'm trying to get to the point where I can actually focus on 8 and 9 for you, because you're not. I mean, you're going to see some of 6 and 7, but for the most part, it's the denominator with the opposite sign. Okay? All right, so let's look at 8 and 9. Okay, this is where we're talking about the sum and difference of 2 cubes. And really, here we're just talking about the difference of 2 cubes. So with this, and I'm going to go ahead and actually pull this over here. All right, so your first question starts off with what? 3x squared y to the 9th minus 375 x squared z to the 15th. Okay. All right, the first thing that we have to do is express our answer as a difference of cubes. So we're going to take out what we can take out. Whatever's common. Notice that they both have an x squared. Is 375 divisible by 3? Okay, what do you get? You get 125. So what I'm left with here is I'm left with y to the 9th minus 125 z to the 15th. Okay, does this make sense? So the first thing that you want to do is make sure that see if it can be simplified with what's already there. So we took a 3x squared out. The next thing I want to do is I want to cube root what's inside my parentheses. Okay? So the cube root of y to the 9th is y cubed. Okay? So we factor this difference. So we'd get y cubed. Over here, we want to cube root 125, which should be 5. And we want to cube root z to the 15th, which would be z to the 5th. Okay, so we have this there. If I multiplied all that back out, I would get my original answer. Okay? Okay. Now, the pattern that we want to follow is going to look like this. It should look like first term minus the second term. And then we want f squared plus, let's see, make sure I've got this, plus fs plus s squared. That's our formula pattern. I believe that you guys saw this in Algebra 2. Okay? So my first term is y cubed. My second term is 5z to the 5th. Okay? So we're just going to keep this y cubed minus 5z to the 5th like this. So this is term 1, y cubed. This is term 2, 5z to the 5th. So the first thing I want to do is now I'm going to follow my template, which is f squared. All right, so we're going to take y cubed and square it. What's y cubed squared? Y to the 6th. Okay? Plus first term times the second term. Now, what I want you to understand is that this isn't y times negative 5. It's y cubed times 5z to the 5th. The second term does not include the negative. Okay? 5y cubed z to the 5th. That's it. Okay? Now, the same thing is true on our last one. It does not include the negative. So 5z to the 5th squared. 25 z to the what? What's 5 times? It's squared though. So you're taking that 5 times 2, not 5 times 5. So it's to the 10th. Did somebody say that? Okay. So this whole thing right here is my answer. Okay? But this is the form of the answer on every difference of 2 cubes question. Okay? What's that? What's an S? S means second term. Okay, so first term, second term. Okay, I've got not hardly enough time to do this last one. Nor do I even see it on here. Oh, was it number 9? Okay, sorry, number 9. So the first thing you would want to do with number 9, in fact, I'll just tell you what the answer to number 9 is. The answer to number 9 is A. So that's what you want to look at in terms of that question. Okay, a lot of stuff in this lesson. You can start to see how things are getting harder and more difficult. Okay? You cannot let yourself fall behind. If you need help, all right, come in before school, stay after school, come in during aware, do whatever you need to in order to stay up, okay, because it's not going to get easier from here. All right.